CRD 3.3 Part 2, Solving Single Variable Quadratic Equations. So we're going to do a little bit of different solving just because we're going to make the questions a little bit harder, and then we're going to end with a word problem. And do know that when you go back to the lesson, there are some with leading coefficients, factoring with leading coefficients, as I'm about to talk about. And then there's one or two word problems that I ask you to do in the book. There is an additional handout of word problems that tends to be hard. In fact, I heard some 8th graders in the past call it the packet of pain. I don't know why they would say that, but so you do need to engage with those word problems. They can be challenging. However, they are on all kinds of things that you will see in the future. They are a realistic application of quadratic equations. And I've seen them on placement tests, on SATs, on all kinds of things in your future. So definitely take the time to engage with them. Plus, they are a big part of your test at the end of CRD 3. So let's start with factoring with a leading coefficient. 3x squared minus 3x minus 18 equals 0. So what's different about this is already in standard form, but what's different is that you've got a 3 at the beginning before your x squared term. That tends to be a little bit harder factoring. And I don't think Linus does a really good job of explaining it. He kind of just assumes you know how. So that's why I wanted to make sure I pointed it out to help you with that. So your first step is to get it in standard form, which it is there in standard form. So I didn't even write that. But when you're going to go factor this, it's not as easy as it has been. So I recommend that first you check for a GCF. That's going to be the easiest step to do first. And oh my gosh, lo and behold, there is a GCF of 3. Okay, excellent. Now, I take a look at my 3. I can't factor the 3, so it's going to just trail me all the way down the problem. It's just going to get recopied. But I am looking at the quadratic that I have left. I want to factor that. So I'm going to take a look and see. I've already taken out the GCF. Now I'm going to look and see if there's any dots. Oh, what's dots again? I did earn candy for that. But dots are difference of 2 squares. They're my favorite kind of factoring because they're the easiest kind, x squared minus 16. It's a difference, a subtraction problem, of 2 perfect squares. X squared and 16 are both perfect squares. And remember, they factor into x minus 4x plus 4. It's the easiest kind of factoring. That's why it's worth looking for. But I have a trinomial, so it's not going to be a dot, so I can check that off because it's not going to work. Now I'm going to list the possibilities of what this could be, and then I'm going to solve it. So this one tends to be a little bit easier. Happens to be, not tends to be. This one happens to be a little bit easier. X and X. I think about all of the things that are going to make a 6, a 1 and a 6, a 2 and a 3, anything else. Oh my goodness, 2 and 3 are going to work. So I do a minus 3 and a plus 2 because I want to get a negative 1 as my middle term, which that will give me. And now I'm going to solve. So 3 is not 0, so 3 will never give me a 0, but one of these two could give me a 0. So 3 is not something I can set equal to 0, but x minus 3 could equal 0, and x plus 2 could equal 0. So my solutions to this quadratic are 3 and negative 2. Okay. So moving on, here's my list again. Check for GCF, look for dots, list possibilities and test, and solve. So my first step is to look for put it in standard form. It already is. Now I'm going to look for GCF, which happens to be 5. Now I'm going to look for dots. Well, there's 3 terms here, so it can't be a dots. So I'm moving on, list my possibilities. So for 8, what could I have? A 1 and an 8, a 2 and a 4. Nothing else could work. So it has to be a 2 and a 4. And 4 will have to be the negative 1 because I need to get a negative 2x as my middle term. It equals 0. I've factored it. Excellent. Now I'm going to solve. 5 will never be 0, but this term could be 0. Actually, I don't need to write the 5 right now. I basically just need to set x plus 2 equal to 0. And x minus 4 equal to 0, and I get x equals negative 2 and positive 4. Done. Next. Okay, now I have a little bit different. Check for GCF. It's already in standard form, so I can start by checking for a GCF, and there is a GCF. X is my GCF. So this one is a little bit different. Now look for dots. Well, this feels like it could be a dots because it has two terms. But this is not a perfect square, and this is not a perfect square. In fact, this isn't even a quadratic anymore. So it looks like I've already got my factoring done. All I need to do is set my product, each of my factors of my product equal to 0. So I set x equal to 0, and I set x minus 8 equal to 0. And look at that, I already have one solution is 0. The other solution would be 8. So that one is a little bit different, and that does crop up in the future. So you will see that. So that's as hard as it gets this lesson. This leading coefficient stuff does get harder. But I believe we address it more in the future, in chapter 5, I believe. So, perhaps actually later in this chapter, but that is as hard as it gets in this lesson. So let's keep going. Word problems. I'm only going to do one, okay? And you might need help in class, and that's absolutely okay. I recommend you do the packet of pain with other people because it will help ease the pain, and I can also help you in class. So, reading carefully is very important, and making a picture is very important. A square garden was overhauled to make it more exposed to the sunlight. It was made 10 feet longer and 6 feet less wide, or deep as they sent to Tafer Gardens. Its new area was 80 square feet. How long was the side of the original square garden? Suggestion, draw a picture to start. So it looks like we need to have two pictures. We need to have the original garden, which was a square, and I'll do my best, not drawn to scale. And then I'm going to make my new garden, which is 10 feet longer and 6 feet less wide. Again, not drawn to scale. So the new area was 80 square feet. Okay, I'll put an 80 in here. How long was the side of the original square garden? Well, I don't know. Well, let's figure it out. It was a square. I didn't know what it was, so guess what? I'm going to call it x. And if it's a square, all my sides are x. So I'm going to label my length and my width x and x. The area of this garden is length times width, or x squared. The area of this garden is 80. Okay, can I use my 10 and my 6 somewhere? In fact, I can. It was made 10 feet longer. So that means it was x plus 10 longer, right? Doesn't that say it's from the original plus 10 more? Now, 6 feet less wide would be what I had. Take away 6. Okay, its new area is 80 square feet. So I'm going to take the area, which means I'm going to multiply my length times my width, and it's going to equal 80. Okay, great. Now I got to solve it. So it looks like it's not equal to 0. So what I need to do is I need to FOIL it out. I need to bring the 80 over. Now it's in standard form. Now I've got to factor it. I got to think about all the terms of 140, all the things that multiply to give me 140. Remember, they have to be roughly 4 things apart. So in honor of going quickly, I'm going to tell you what they are. It's 14 and 10. And 10 is going to be negative. 14 is going to be positive. And I get x plus 14 equals 0. X minus 10 equals 0. My answer is x equals negative 14 and x equals 10. Well, I've solved it, but have I answered my question? Remember, it says the new area, how long was a side of the original square garden? So I'm looking for this x right here, which I believe I just found. It says x is 10 or negative 14. Could it possibly be negative 14? No, it couldn't. So what I do is I throw away one of my solutions because it doesn't make sense within the problem, and I state in a sentence, the original garden was a square with side length, and you could probably find a faster way to say this. I'm going very long. Side length of 10, and what is it? 10 what? Feet. Now I've completely solved this problem. Okay, good luck. Make sure you do drawings, ask for help, and you will be fine.